everyone. So these are the topics that we're going to talk about in Tricky Topics Chapter 3. This video is only going to be over this first one, conditional probability. So let's go ahead and dive into that. All right. Conditional probability is going to be whenever you have some additional information about a person and you have to adjust the probabilities to account for that. So for example, let's say that I tell you that people have a 33% chance of having blue eyes, a 33% chance of having brown eyes, and a 33% chance of having green eyes. And now I tell you, I don't have blue eyes. What is my chance of having brown eyes? So if you look back at these probabilities, I tell you I don't have blue eyes, which means that it's no longer a 33% chance I have blue eyes. It's now a 0% chance I have blue eyes since I told you I don't have them. So if we look at the options that are left, we see that they're in equal proportion, and I have either brown eyes or green eyes. So now I only have two options. I either have brown eyes or I have green eyes. And we know that if I have two options, each of these has a 50% chance of happening, 50% for green eyes and 50% for brown eyes. So if I don't have blue eyes and I either have brown or green, I have a 50% chance of having brown eyes. And notice how we changed those probabilities to still add up to 100%. So obviously my 33s don't add up to exactly 100%. Just imagine there's also that 0.33333 tagging along at the very end of it. But then we changed it to 50% and 50%, so it always adds up to 100%. The other way that you would do this is if it was fractions, you would make sure it adds up to a whole. So for example, 1/3, 1/3, and 1/3 changes to 1/2 and 1/2. So let's do another example. Same 33% here, here, and here. But now I tell you, I don't have blue eyes, and I also don't have green eyes. Now what is my eye chance color? Well, if I don't have blue eyes, that's no longer a 33% chance, that's a 0% chance. I don't have green eyes, that's now a 0% chance. I only have one option left. So it's not a 33% chance I have brown eyes when that's my only option. It's a 100% chance I have brown eyes. So based on some additional information that you knew about me, you had to adjust the probabilities that we were using as we were solving a problem. So the key here is to always make sure that your percents add up to a whole and all your fractions add up to, percents add up to 100, your fractions add up to one whole after you cross one out. So let's do an example to make sure that we got this. So I tell you that butterfly wing length is determined by a gene on chromosome 5. If this gene is dominant, the wings are long, and if the gene is recessive, the wings are short. Two heterozygous butterflies are crossed and they have a child with long wings. What are the probabilities of the child's genotype? So let's draw some stuff out. So I know that I'm going to do big L is my dominant one, and this is long wings. And then I'm going to do little l is recessive, and this is going to be short wings. In the problem, I tell you that we're crossing two heterozygotes. So that means that we have big L little l and big L little l, because remember, heterozygote has one dominant and one recessive. So we should have these genotype ratio memorized. I'm just going to go ahead and write it out, and we'll also draw a little square so that you can see it. It's one homozygous dominant to two heterozygous. Remember, this includes both big L little l and little l big L, to one little l homozygous recessive. If you were to do the box, you would write your parents' phenotypes on top and then just cross them in here. So that's what it looks like right now. We have 1/4 chance of big L, 2/4 chance of being heterozygous, and 1/4 chance of being little l. So that would originally be our probabilities of the child's genotype, except that I gave you guys some additional information. And you'll notice when you look at this that a lot of times it's not super obvious that it is additional information because it flows very well with the problem. They have a child with long wings. It can be super easy to miss this kind of stuff since it's not written out in its own sentence. Like, here's some additional information about the child. They have long wings, where it's super obvious. It can just be really, really simple. Another way you'll see it is if a problem is about a disease and it says, the couple has a child that does not have the disease or something like that. And you kind of read over it, but it just kind of leaves your head right away. So make sure that you're paying really close attention to when something says anything about the phenotype of the child. Okay, so let's go back to solving this now that we know where that conditional probability is. So we know our child has long wings. So if we look at our options, first we know long wings is dominant, and that means that you only need one dominant allele to have long wings. So we could be homozygous dominant or heterozygous. But we're definitely not homozygous recessive, because if we were little l, we would have short wings, and we don't have short wings. So that means that this option right here is not an option, which means that this 1/4 chance just changed into a 0 chance. There is no chance that we are little l, because we have long wings, and little l is for short wings. So now if we were to look at these probabilities right here, 1/4 plus 2/4 is 3/4. So, but those are our only probabilities. We need our probabilities to still add up to be 1, since those are our only options. So if we look at them right here, there are only 3 boxes. One of those boxes, so one of the 3 boxes is homozygous dominant, and 2 of the 3 boxes are heterozygous. And you'll notice now that our 1/3 plus our 2/3 equals 1. Yay, that's what we want. So that's a really easy way to check yourself with conditional probability. After you cross something out, do your probabilities still add up to be 1? If not, you need to change them and make sure they do. And if they do, then you're all good. So this would be our answer for this problem right here. 1/3 chance homozygous dominant and 2/3 chance heterozygous. All right, so that was conditional probability. Our next video is going to be over binomial expansion.
I hope you found this video really helpful. The concepts and information presented in these videos will be true no matter what genetics class you are taking. However, the concepts presented in this video are referencing material currently covered in Baylor University's coursework. Remember, if you are currently enrolled as a Baylor student, we offer free tutoring services. Our tutoring center is located on the first floor of the Sid Richardson building. You will find all the details you need to know about these services on our website, www.baylor.edu/tutoring. You may schedule a free 30-minute one-on-one tutoring session online through Navigate, or just drop in during our open business hours. For more information about our current services, please visit our website. Thank you.